Hi folks, so in this problem here what we have is an orthographic problem. So it says here the 2011 section B ordinary level. The 3D graphic to the left shows a model for a fireplace. The figure B3 shows the plan and elevation of the fireplace. So we can see it here, figure B3. We've got the elevation up here in the plan. Okay, draw the given plan and elevation. Then part B, draw an auxiliary elevation of the fireplace projected from the plan, which will show the true shape of surface A. And we can see that surface A is here in elevation, which is identified by this edge view here in plan. So let's start that. Now, because we want to show the true shape of surface A, when we look at the question, we actually have to identify it. I'm just going to highlight that surface there. That's what the surface looks like in the plan. So the only way I can see the true shape is by taking a view looking perpendicular to it. And that means when I take that view to look at that face, I'm going to be projecting in this direction, over here in the direction of the pencil, which means that I'm going to need space on my right hand side. So therefore my elevation, my plan, are going to go on the left hand side of my page. Okay, so to start off those there, I'm going to start about here, I think, in line with that. So there's my XY line, and straight away the overall length of it is 100. I'm going to measure 100. 0 as far as 10. Okay, and now that I've done that, I want to do the overall height, which is 75. So there's the 75. Now, there's the elevation done. While I'm at it, I'll pop it in. I'm heavy in the whole outline, because that is heavied in. So there we go. There is the starting of the elevation. There's my XY line. Now what I want to do is I'm going to put in some heights. So I have a height of 10. So if I measure up 10, line across, and then I need to find the middle. I'm assuming the door is in the middle. So half of 50. It doesn't say it or anything there. It doesn't give us a measurement technically, but I'm putting it in. Assume it's going to be in the middle. So I'm going to measure in 50 there, do a line up and down, and from the middle I'm going to measure 20 to the left, 20 to the right, and I'm going to do a line up here, and a line up here, and I'm going to measure 40 up. So there's 40 there, and it's 50 up to the very tip top. So 4 up as far as 8, and 4 up as far as 9 is 50. Okay, and do a line across here and join those together. Okay, so there we have it, folks. Drawing the elevation now. Heavy everything in. So that is our elevation almost complete, missing a little bit there. Now I'm going to work onto the plan. So bring the length down and down. I usually keep a gap of about 1 centimetre. And then over here on the right hand side you can see the measurement is 10 and 30. So 40 wide altogether, or 40 in depth or width. So 10 is 30. Line across. Line across. And then what I have to do is from the middle, I want to do the middle, I'm going to bring that down. From the middle, you can see here the length at the front is 80 for that bit, which means I'm going to measure 40 to the left and 40 to the right. Okay, so now that I've that done, what I'm going to do is you can see the angle here for this little edge here and this edge are going to be at 60 degrees. So from these 2 points, I simply go 60 degrees like this. And then 60 degrees once again like this. And there we go. So there's our 60. And our 60. There's our 260 degrees. And let's start drawing on the plan view. And almost done. Now, to finish off the plan, or sorry, to finish off the elevation, I can bring this guy up now, and this guy up, and that will identify to me where surface A is, here and here. And then, to finish off the plan, this will come down. The middle one is already down, because technically, looking down on top of it, there's going to be edges inside and under here, and these are going to represent the door. And there we go. So there is our elevation complete, part A of the question done, elevation complete, and our plan complete. Now what they're asking us to do is draw an auxiliary elevation of the fireplace projected from the plan, which will show the true shape of surface A. And surface A is this surface right here. There's surface A, so I'm going to write in A there. Okay, this is A in there, looking in that direction. So just for highlighting purposes, that's the surface there. Now, anytime we want to see the true shape of something, rule number one is identify that surface as an edge view if we don't have the true shape. Surface A in elevation is not a true shape because the line in the plan is not a horizontal line, it's at an angle. Because when we're looking in at the elevation, it's like I'm taking my biro here and I'm looking in this direction. So technically this front surface, that guy there, the long rectangle at the front, is a true shape. But the guy at the side, surface A, is not a true shape. The only way I could see that as a true shape is if I was standing here in the plan view, there's my shoulders, and I'm looking in this direction. And when I look straight at something, I will then see it as a true shape. And to do that, then we take an auxiliary view. Now, we're taking an auxiliary view, but we're drawing the overall object as well. So imagine here now, there's a series of arrows just showing what we're looking at, all in that direction. So there's a series of arrows, okay? If I was standing here, I would see this, I would see this, and I would see this. The faces I won't see is this face here, because it goes around in the direction of my finger there, pointing in that direction, or the biro here I should say. I can't see this face, I can't see this face. I can see the front, I can see this bit here, the yellow bit, which is going to be the true shape, and I can see this. Okay, so that's what we have to do. So what's helpful here is I'm doing what's known as an auxiliary elevation. Okay, draw an auxiliary elevation projected from the plan, which will include the true shape of surface A. So part A here, this guy here, which is at 60 degrees, I'm going to set up my auxiliary view parallel to that. So out around here, that is going to be known as my x1, y1. And what I'm going to do is I'm going to project out all the points on that surface. I'm going to start with surface A. So they'll go out then at 30 degrees. The reason I'm going at 30 is because 60 plus 30 makes 90, and that's a perpendicular angle, 90 degrees. So those two guys are just after projected out. Now how do I work out this guy? So what I do is to find surface A, there's 4 points on surface A. There's 2 points on the ground, okay? So they'll be here and here, okay? Because this is technically just representing the ground again, the x1, y1. And then there's 2 points that have a height of 10 millimeters. So if we project from the plan, we take our heights from the elevation. So I take my heights from the XY line up, I'm going to find it up here, so I mark it out like this, there, and there. And there we go. So now, I'm going to get surface A, just like that. Okay. And there is my surface A, and that is the true shape. So I'll put that in yellow again, just to have it done. Okay, so now that we've got that surface, technically I've drawn this surface here. Can I see a bit of the L-shaped surface here on the side? Okay, so let's identify that. That L-shaped surface, hopefully you can see it there on the screen. I'll zoom in a little bit more, so you can see it a bit better, apologies. So that L-shaped surface is this guy here, attached onto surface A, which is actually this line here in the plan. So what am I going to do? I'm going to project that out at 30 degrees. Okay, the reason I'm using 30 is because the x1, y1 is at 60. 60 plus 30 makes 90. So that'll come out, and the other point here will also come out. Okay, now how do I find the overall height of that face there? Okay, so that face here is this height. So from the xy line, I'll take the overall height up to here. Take that height, okay, you can see the height that I'm taking there, like that, and I follow it out here, and I want to mark it up on the 2 appropriate points, here and here, because that'll give me the height of that point and that point. Okay, now technically if I just marked one of them and went at 60 degrees, there's that one. So there we have it. That guy goes down as far as there. Now what I also want to find is this point in here. So how do I find that point? Well, really handy is I could simply just take 10 and mark it up, but if I just go at 60 degrees like this, we get it there. And there's the L. So now let's heavy in that L. So it's just taken face by face. Now the more advanced you get at this auxiliaries, you'll start to realise that you'll get quicker at it. Okay, but if you struggle at the start and you're trying to improve your understanding, just take it surface by surface, which is what I'm doing here in this video. So there we go. Now I've got the L-shaped surface at the side, and that's what it looks like when I'm looking in this direction. Okay, that's what I'm actually seeing. I'm not seeing the true shape of it, but I am seeing that. Now I'm going to get this long surface here at the front, that rectangle there. So that comes from this point and this point. So what do? Project out 30 degrees, and then it has to be the same height as surface A, so I'm just going to go down at 60 there, and there we go. And there's that rectangle. So I can see that as well. So there we go. We've got the L shape, we've got surface A, and we've got the rectangle. L shape, surface A, and rectangle. Now I need to actually work on to what I can see for the face. Okay, so I'm going to focus on this little surface here, including the door. Okay, so what's helpful here is, do I have the overall height? Yes, I do. I've already put that in. So if I track this line down at 60 degrees, that's where it's going to be. Now, where does this edge here end in the plan? So we've already got this line, because that's that guy. Where is this line? I need to find that guy. So where is that? Well, it's right here in the plan. It's that guy right there. So what do I do with that? I'm going to bring it up. And that's going to show to me that rectangular surface. Now, what's missing off that front face? What is missing off that front face? Clearly I'm missing the door. So I'm missing the front of the door. Okay? So how do I get that? I have to identify the 3 points on the front of the door. One is here, and one is here. So how do I find those? I'm going to project them out at 30 degrees. You could use indexing here. Out at 30 degrees. 30 degrees, and 30 degrees. So how do I get the heights for the door? I'm going to mark them up from the XY line. So, to get the right hand side of the door, see that guy there? I take the height from the XY line up as far as the point I want. Here's the guy that I'm referencing off. Follow it up here and mark it from the X1, Y1. Now what's helpful here is that's also the same height as the left hand side of the door. So I can use it on this point here. Follow it up. Make sure you mark it from the correct spot, and there we go. And then the last one I need the height for is the top of the door, and that's the middle guy. Follow it up, and there's the top. Okay, so now that we've done that, let's heavy in the door, and you'll see, because I'm looking at the door from an angle, it looks like it's after getting squished, essentially. And there we go. So there is the door. Now, as I'm looking in at it, the door has a thickness. So now I have to start thinking, can I see this back edge in here? So how do I find that back edge? So that's going to be these 3 points. Here's the back of the door, because the door is at the front and it's also on the back surface. 1, 2, 3. So I have to project up these points now. So, starting with this one. And what's helpful about that one is that back edge there will be the same height as this one. So if I use my 60 degree set square and just go out like this, and there we go. So there's that bit and that bit. So I've got the inside face. Now I have to get the slope. So how do I get the slope? Well, the same principle. I need to now find the top point. Okay. And then it's going to be at the same height as this guy, so if you go at 60 degrees, it's going to go back to there. And technically that line will connect down to here. Now what's important to recognize here is there's only a bit of it that I can see from this direction when I'm looking in the direction of arrow A. Okay? I can see that. Inside there, it'll actually go in as hidden detail. There we go. So I've got some hidden detail there now. And it's going to be the same concept with this edge on the door as well. Excuse me. Okay. Just have to get up and move there, girl, sorry. So, to complete that guy, I'm going to extend the back edge out. That's the one that's at this height, which is the same height as this. So go at 60 degrees then. Okay, and that would simply connect up to here. The problem with all of that though, I can't see any of that. So all of that would actually have to go in as hidden detail. And then this line here. So I've got the door, but I have to be able to show the hidden detail. So there's our hidden detail applied. Okay, so there we have the door. Now, last thing I would also check for at the end of any question is there any other hidden detail? Technically, there'll be an edge running down here at the back as well. Okay, that edge is coming from there. So I have to bring this guy up. And that's going to be a hidden detail line going the whole way up from the ground. Okay, and then there's also an edge right here at this point, which is the other kind of slanted surface on the bottom. So bring that up, and there we go. And that's it. Looking at that there, I'm pretty sure, yeah, I'm pretty sure we're good. So there's the question done, guys. A little tricky question there, okay. All we were doing was projecting an auxiliary view to show the true shape of surface A, which I've highlighted in yellow in all the views, and that one there is actually the true shape inside there. So I'll just pop a little arrow in there. That one is our true shape. Okay, but we have to draw what the rest of the object looks like when we're looking in from that angle. Okay, so there you have it, folks. I hope you found that helpful. All right.